Hello, good day. Sir Howard here. Welcome to our second part of discussing the value of norms in the field of psychometrics. Kung hindi mo pa napanood yung first video on the value of norms, I suggest you first watch that video bago ka magpatuloy dito. But just to summarize, ang pinag-usapan lang natin dun sa first video about norms is norms are important in the field of psychometrics because it gives us meaning to scores. Nagkakaroon ng kahulugan yung mga raw scores na nakukuha natin if we compare it to a norm. At bakit mahalaga na ang score ay magkaroon ng meaning o ng kahulugan? Because from there, malalaman natin what should we do about that person who got that raw score. Bibigyan ba natin siya ng scholarship or kailangan ba niya ng remedial classes? Kailangan ba niyang ma-accelerate sa isang grade level? All of those things, we will not be able to decide kung hindi natin alam yung interpretation nung raw score. So that's the whole point of part 1. Now let's move on to part 2 of our discussion on the importance of norms in the field of psychometrics. Okay? Ituloy natin. Remember, the definition of norm is these are set of scores from the past performance of group of individuals to which the raw score from a psychological test is compared to. Diniscuss ko rin ito sa part 1. Ang norm gawa saan? Set of scores. Galing saan yon? Past performance ng mga tao na kumuha ng isang psychological test. We collected all those scores. Yun yung ginawa nating norm. For what purpose? Any raw score, any new raw score na makukuha natin from people who will take a psychological test, doon natin siya ikukumpara. So, norms look something like this. This is the norm coming from Wechsler. So, on the left column, nandyan yung mga ranges of scores. Kapag yung score mo bumagsak sa any of those ranges, in the right column, it tells you kung anong ibig sabihin nung score na yon. Ito naman yung norm ng Stanford Binet. The same idea. On the left column, maraming mga ranges of scores. So, somebody takes a test, he gets a raw score. Titignan natin kung saan siya bumagsak dyan sa ranges na yan. And on the right column, malalaman natin kung anong ibig sabihin ng score na yon, given the range to which the score fell into. Okay? This one is another example of a norm coming from a standardized psychological test. Again, pretty much the same principle. Okay, we want to know the meaning or we want to compare the raw score to the norm para malaman natin kung ano yung ibig sabihin ng raw score. Okay, raw scores or norms give the score a meaning, and this will be the basis of our description, our actions, and our decisions for those people who are taking a psychological test. Kapag wala tayong norm na ginagamit, we only have the raw score, we don't know the meaning of that score. However, kapag meron tayong norm na pinagbabasihan, the raw score, that 59 over 100 right there, malalaman natin if 59 over 100 is excellent, above average, average, or below average. And one thing that I also want to repeat from the first lecture on norm, tatandaan natin, ang norm ng isang standardized psychological test is being constructed. Ginagawa ito. Kaya alam nyo, sa test development, napakahalaga yung proseso ng pilot testing. When we do pilot testing, when we administer the test to sample populations, kinukuha natin yung mga raw scores ng mga tao na yun, and then we collate them, and then we apply different mathematical formulas or mathematical techniques para mabuo yung norm na pinakita ko kanina, such as this one. So again, let me repeat, this norm is something that you construct. At para magawa mo yung norm na yan, you need to undergo the process of pilot testing. That's why in test development, isa yan sa mga phases na pagdaraanan ng isang test, no? Where the test is being pilot tested to populations so that we can know or we can establish the norm of the test. Usually, this happens at the later phase bago i-release yung test sa market. Madalas ano yan eh, after na ito ng reliability, after ng validity, now you establish the norm of the psychological test. And in the first video, kung naaalala ninyo, sinabi ko doon that there are 5 ways or techniques that we can use para makagawa tayo ng ganyan. Pwede mong gamitan ng measure of central tendency, frequency distribution, normal curve, percentile rank, and the stay 9 system. So the next series of videos that we will have magpo-focus on how exactly do you apply these techniques so that you can come up with a norm pretty much like this. Okay? Now let's talk about numbers 1 and 2, measure of central tendency and frequency distribution. The first technique, measure of central tendency, let me demonstrate how we can use this para magkaroon ng meaning yung mga raw scores. Imagine, there is an intelligence test na ginagawa natin. We are developing this. And then we pilot tested this intelligence test to 40 people. Now, for the sake of example, again, 40 people is very few kung ikaw ay nagno-norming na, no? But again, just for the sake of example, imagine that there are 40 people being pilot tested here. But in real life, you need more than just 40. The more, the better. So given this step, okay, pilot testing this test to 40 people, how can we construct the norm? How can we use measure of central tendency to know kung sino ba ang pass, sino ang failed? So let's have a hypothetical raw scores. So these are 40 people. That means you will see 40 different scores. Okay? Now, again, the basic question is who passed and who failed this test? Again, kapag wala ka pang norm, the answer is we don't know. If I pick any score from the 40, and then if I ask you, pasado ba o hindi? O, is 47 passing or a failing score? How about 53? How about 41? How about 60? How about 28? 'Di ba? Hindi mo pa masasagot at that phase because wala pa nga tayong ginagamit na technique to establish the norm. So at this form, all these raw scores are simply raw scores without any meanings. So lalagyan ngayon natin ng meaning yung mga raw scores na yon by using the measure of central tendency, and when you hear those words, you know we're talking about the big three: mean, median, and mode. Yung mean, yun yung average ng all scores. So you add up all raw scores divided by the number of cases. That will be the mean. Median, you organize the scores from highest to lowest. Tapos hahanapin mo yung middle point of the distribution. While mode, hahanapin mo yung scores that are the most frequent in occurring in the distribution. So yun yung tinatawag nating big three, the mean, median, and mode. So let's use each one of this para mabigyan natin ng kahulugan yung mga raw scores na nakita natin kanina. Let's start with the mean. So again, anong gagawin natin sa mean? You add up all the raw scores there, all the 40 scores divided by 40, which I already did. The mean here is 53. So ano ngayon ang magiging silbi ng 53? Now that we know that the mean of the distribution of these scores is 53, we can use the value of 53 as an indicator who passed and who failed. So ibig sabihin, yung mga scores ngayon na mas mababa sa 53, we can label it as failed, while those scores that are equal to or above 53, we can label as passed. So tignan nyo yung difference dito. Dahil nag-measure of central tendency na tayo, now it's easy for us to know kung yung isang score ba ay pasado o bagsak. 55 is passed, 52 is failed, 47 is failed, 60 is passed, 68 is passed, while 42 is failed. O, di ba? Bakit ako siguradong sigurado sa ibig sabihin? Because I already have the mean to help me determine the meaning of the raw score. How about the median? Remember, ang median, i-organize mo muna yung scores from highest to lowest, and then you spot the midpoint, the middle score in the distribution. So, maraming, ano yan, no, may mathematical formula dyan on how to get the median You just research that on your own, but that's the logic of median. Hinahanap natin yung middle score in the distribution of scores. Now, I already did this for you. Ano ang median ng mga scores na ito? It's 54. 53.5 rounded up to 54. Ano ngayon ang silbi ng 54? The same logic. Any scores that will fall below 54 failed. Scores 54 and above passed. So given this, madali na naman nating masabi kung anong ibig sabihin ng bawat raw score. 65 is passed while 47 is failed. 44 is failed while 56 is passed. Okay, so that's what we do in median. Yung mode naman, hahanapin lang natin kung ano yung mga scores na pinakamataas yung number of occurrence in the distribution. In this case, we have two modes. And that's possible, no? That's possible. Dalawa yung modes mo. So, meron kang 56 at meron kang 42. So, how do you decide now? Ano ngayon ang magiging basihan mo dyan to know if the score is pass or fail? It's up to you. Dahil dalawa ang modes mo, as the test developer, you have the right to choose kung ano yung score na gagawin mong pang-cut off ng pass and fail. If you want your test to have a higher standard, then piliin mo yung 56. Kung medyo mababa lang yung standard na gusto mo, then you choose 42. So that's how you use the big three in determining or giving meaning to the distribution of scores. But we have to talk about the disadvantage of measure of central tendency. Kasi to tell you, this is rarely being used. Hindi masyadong ginagamit itong technique na ito in test development because of a very obvious, should I say, problem. And what is that? The interpretation of scores using this system is very general. Or in another words, napakababa lang ng variation of the labels that you can come up with this technique. In fact, gaano kababa? Dalawang variation lang eh. Pag gumamit ka ng measure of central tendency, it's either somebody passed or failed. And in many instances, in everyday life, we need more than just who passed or who failed. Hindi naman hindi naman ganun ang pananaw natin sa everyday life, no? Hindi naman tayo black and white mag-label ng scores, no? Hindi lang tayo basta passed or failed. Let me demonstrate what I mean. Imagine, meron akong set of scores, hindi ko na lang nilagay dyan, but I use the median system to determine the cutoff. Sabihin natin 50. So yung 50, all scores that will score below 50 fail, scores 50 and above will pass. Okay, now, let's pick two students. Student A is 99. Anong interpretation nun? Definitely passed because 99 is greater than 50. Si student B, eksakto 50. O anong interpretation nun? Pass din siya. Now, in everyday life, that's going to be unfair. Although tama naman yung interpretation natin, pareho naman yung equal to or greater than 50, but you see, there must be a distinction, right? There must be a distinction between someone who really did well in that test na naka 99 siya and someone na muntik nang bumagsak sa test. Nakasabit lang siya sa eksaktong cut-off na 50. Kasi kung ikaw yung student A, di ba parang masakit sa loob mo yan, no? Na ang tawag sa'yo, passed. Pareho lang ng tawag sa'yo yung isang estudyante na muntik nang bumagsak. Pareho lang kayong passed. So are we saying na pareho lang sila ng degree of performance? Definitely not. The 99 was better than the 50, but measure of central tendency looks at scores that way. Ganun talaga eh. Dinidivide lang ng central tendency yung distribution of scores into two kinds. Who passed and who failed. Who has high scores, who has low scores. So, wala tayong masyadong variation of labels na makukuha when we use the measure of central tendency. That is why, to solve that problem, maraming mga test developer, they would rather choose frequency distribution para to address this kind of problem. Let's discuss. Paano ba ginagawa to? Again, For the sake of example, we have the following scores. This came from the pilot testing of a test that we are developing. Okay, mga hypothetical scores lang ito. Now, how can we use frequency distribution para makapag-establish ng norm? Step 1, you are going to identify the range. At alam naman natin, statistics 1 pa lang, ano ang formula ng range? The highest score minus the lowest score. After you get the range, now you identify the interval size for each class interval. In this system, ang gusto nating marating, ang gusto nating ma-achieve is we will be able to organize the scores this way. Gusto natin sila ma-organize according to class intervals. So, bawat isang range dyan is called a class interval. Now, you have to be familiar with the term interval size. Ano bang ibig sabihin yan? Ilang interval size meron sa isang class interval? Well, bibilangin mo lang yung lower limit, number of units between the lower limit and the upper limit. In this case, the lower limit is 51, the upper limit is 54. So, papaano ang bilangan yan? Huwag kayo malilito, no? Ano ang interval size ng 51 to 54? You count it this way, 51, 52, 53, and 54. Okay? So, in that case, using that system, then you have 4 units within the class interval. Maliwanag ba? So, yung class interval na yan, every range, meron siyang 4 units inside that range. But the question now is, how do you compute for the interval size of that class interval? Merong formula dyan, and the formula is range divided by 15. And this is constant. Divided by 15 is constant. Sabi ng mga statisticians, ang pinaka-format talaga ng isang matinong frequency distribution is at least meron kang 15 class intervals. Mag-iiba-iba na lang yung iba't ibang mga norms depende sa size ng interval, the interval size. Alright? So, but again, the interval size is computed range divided by 15. 15 is constant. So, how did we do this in that example? 82 minus 28 divided by 15, that gives you 3.6, or you round it up to 4, doon natin nakuha yung interval size na 4. Okay? That's why going back, baka malimutan nyo, ayan, bawat isang class interval dyan, merong 4 units. Where did we get that 4 units? By applying the formula range divided by 15. Okay? Now, let's move on to step 3. Now that you know the supposed interval size for each class interval, it's time for you to organize the class intervals of the raw scores. So, usually, syempre, magsisimula ka sa pinakamababang score na nakuha sa distribution. So, the lowest score, for example, in my pilot scores is 28. And the interval size is 4. Paano natin nakuha yung 4? Range divided by 15. So what do? We go to the lowest class interval. So 4 units, no? Di bibilangin mo kung ilang units. Bibilangin mo yung 4 units from the lowest score, 28. So 28, 29, 30, 31. Gets? And then, akyat ka na naman sa next class interval, 32, 33, 34, and 35. Akyat ka na naman sa next, 36, 37, 38, 39, hanggang sa maabot mo yung range, yung class interval that contains the highest score. Maliwanag ba? So, yun na. Kapag in-apply mo na yung step na yun, you will be able to come up with these class intervals. Now, step 4. Ngayong naayos mo na yung class intervals, syempre, a-assignan mo na ngayon ng meaning yung mga class intervals na yan. So, what do you call a person whose raw score ay nandoon sa 27 to 30? Anong tawag mo kay Pedro na ang score niya is nandoon sa class interval na 59 to 62. Anong tawag mo kay Judas na ang score niya ay nandoon sa 79 to 82? There are two approaches. How do you assign meaning to these class intervals? Number one, pwede mo siyang daanin sa median. Diba? So, ang gagawin natin sa approach number one, you simply compute for the median of the distribution. Pag naspatan mo na yung median, hanapin mo nasaan yung median na yon, which class interval can you find the median. Halimbawa lang, yung median sa distribution na ito is 47. Oh. Nasa ang class interval yung 47, nandoon sa 47 to 50. Now, kapag na-identify mo na yung class interval that contains the median, now you can select two class intervals above and two class intervals below at yun yung gagawin mong average. Yun ngayon yung lelabelan mong average. So, anyone whose raw score falls within any one of this class interval, 55 to 58, 51 to 54, 47 to 50, 43 to 46, 39 to 42, ang tawag natin sa mga nilalang na yan ay mga average. Okay, so that's a system that you can use para malaman mo kung ano yung meaning ng mga class intervals na yan. And then i-adjust mo na lang, no? After average, you have above average, the next three, and then the next three, you have the superior. And then sa baba naman ng average, you have low average, and then sa baba ulit nun, last three, very low average. I hope that's clear. All right? Another approach that we can use to assign meanings to this class interval would be getting the frequency. Okay, medyo mas complicated to, no? Ibig sabihin yan, hindi mo siya dadaanin sa median. Kailangan mo pa malaman yung frequency of scores of the distribution, such as what you can see on the screen. So, ang gagawin natin dito, hahanapin lang natin yung bulk of scores or the bulk of frequency in connection to the class interval. Saan lumobo? Anong class intervals lumobo yung mga cases? So in this case, mukhang lumobo yung frequency doon sa class intervals na 43. Actually, isama na lang natin yung 39 to 42, 43 to 46, 47 to 50, 51 to 54. Yan ngayon yung gawin mong average. Tapos, i-adjust mo na naman, above average, superior, sa pababa, low average, and very low average. Okay? Now, here's the problem. No? Ang problema dito sa frequency distribution, especially the second approach, no? In connection to second approach, what if yung frequency mo dito sa middle column, hindi ganyan ang itsura? Papaano kung lumobo sa taas o lumobo sa baba, hindi sa gitna? Kasi ito, ano to no? Ideally, when you pilot test a population and you get the raw scores, hindi naman laging ganyan yung itsura ng frequency. In other words, let me use statistical language here. There are times that the distribution is not always normal like this. Kasi ang itsura ng normal distribution, 'di ba, is yung extremes mababa, tapos yung mga class intervals after the extremes pataas, yung pinakagitnang distribution of scores, yun ngayon yung lolobo. O yun yung mga average. Pero hindi nga laging ganun yung itsura. Minsan ang itsura ng frequency distribution is like this. Lumobo doon sa extreme high scores. 'Di ba? What does this mean? It means that the test is too easy, or maybe the population you use is simply too smart, hindi sila varied, hindi sila representative of a population. So yung iyong normal curve, again using statistical language, is skewed to the left. Oh, in this case, hindi mo pwedeng gamitin 'yan. Hindi mo pwedeng sabihin na edi gawin nating average yung 71 to 74, 'di ba? Kasi masyado naman magiging mataas yung iyong standard when you do that. Or halimbawa, pwede ring baliktad. 'Di ba? Yung naglobo yung mga extreme low scores, which means Your test was simply too hard, or maybe the population you use is too incompetent, hindi na naman siya varied, hindi na naman siya representative. So your curve here, the normal curve is not normal but is skewed to the right. You see, again, kapag ganito ang iyong data, hindi mo pwedeng gamitan ng ganyang strategy. Yun lang ang problema if you plan to use uh, this approach in assigning meaning to the different class intervals. So, again, if the distribution is not normal, ano ngayon ang response mo dyan? Make it normal. So, nag-pilot test ka. Nakita mo, hindi normal yung distribution mo, hindi mo pa siya pwedeng assignan ng meaning. 'Di ba? Ang gagawin mo, you would go out again in the field, you gather more scores, or maybe you select more appropriate population para matanggal yung extreme results until mag-normalize yung distribution mo. And by the way, how would you know kung yung distribution mo is normal na o hindi pa? Merong statistical technique na ginagamit dyan. Ito yung tinatawag nating Shapiro-Wilk test of normality. Or in some cases, gumagamit tayo ng Kolmogorov-Smirnov na test. Either way, Kolmogorov-Smirnov or Shapiro-Wilk, these are statistical methods that will tell us kung normal ba yung distribution. And just a little bit of statistics here. Ang tinitignan natin dito is of course yung SIG, yung significance. Yung sa logic ng test of normality, we want the significant to be high. Kasi 'di ba usually in testing or even in psychological research, we want the SIG to be less than 0.05, 'di ba? Pero dito, gusto natin greater than 0.05. Because what this tells you, kapag greater than 0.05 in the language of statistics, your scores that is not significantly different from a normal distribution. So kapag greater than 0.05 yan, yan ang sinasabi sa'yo ng statistical software. Normal ang distribution mo. Walang pinagkaiba yung scores mo, yung distribution ng scores mo sa isang typical na set of scores na ang shape ay normal ang distribution. Now, the problem is kapag bumaba ng sobra yung SIG na yan, nag less than 0.05, ang logic nun is your distribution significantly differs from a typical normally distributed scores. That's why, again, sinasabi ko na regardless of this test, KS man yan or SW, you want the SIG to be greater than 0.05. Okay, so let's leave the technical side of these statistical techniques, no? Pero focus tayo ngayon dito. What is then the advantage of frequency distribution? I think the advantage is very obvious. If you are going to connect this technique to measure of central tendency, you will realize that using this system, now we have a variation, more variation of labels that we can assign to different scores. Nakukompute din natin yung degree and the extent of the label. Halimbawa, hindi ka lang basta-basta pass. Sa central tendency, yun lang yung makukuha mo pass. But of course, in real life, we want to know gaano ka kapasa. Are you an average pass? Are you an average pass? Are you an excellent pass? Because again, that can guide you what decision to make for that person. O, pag alam mong excellent siya, definitely, ibigay mo sa kanya yung scholarship. Hindi mo ibibigay yung scholarship sa isang average lang or even above average kung talagang stringent yung scholarship. O, 'di ba? So, hindi lang basta-basta pass. Anong klaseng pass ka? Average, above average, or excellent? Now we know using this system. Ganun din naman sa fail. Anong klaseng fail ka? Low average or extreme low average? Or below average? Hindi ko lang nalagay dyan, no? And again, those variation of labels can further give you, can help you identify right solutions for for the client who took the test. Okay, so that's the main advantage of frequency distribution over the measure of central tendency. Yun lang. Eh, mas matrabaho talaga yung frequency distribution, but it's worth it. Lalong-lalo na kung yung goal mo is to have a variety of labels across different scores. And also, just a gentle reminder, hindi naman natin na kino-compute yung mga yan manually. Whether you're using central tendency or frequency distribution, hindi na tayo nagmamano-mano, no? Unlike what we do in elementary statistics 1 classes na minamano-mano yan, but naging ano na, no, nag-improve na yung mga softwares natin ngayon. All of these things can be done in a matter of seconds. May mga ikiklik ka lang, alam mo na yung mean, median, mode, gagawan ka na ng frequency distribution, malalaman mo na kung yung distribution mo is normal or not. So, technology will do all these things for you. Okay, it's just that, ito ha, yung mga magbo-board exam, ang suggestion ko sa inyo, kahit na ginagawa na ito ng statistics for us, okay, eh sana pag-aralan nyo pa rin gawin manually. Pag-aralan nyo pa rin paano mag-manual compute ng mean, median, and mode. I-review nyo ulit yung procedures, paano gumawa ng frequency distribution, because by doing that, you can deepen your understanding of the process, and hindi mo lang maiintindihan yung concept sa conceptual level, malalaman mo rin yan matututunan mo rin yan in the practical level, which will improve the imprinting of the memory in your mind. Diba? So kahit na ginagawa na to ng mga tools, gawin nyo pa rin ito manually just to further improve your memory of these techniques. Okay, so this ends our second installment of talking about norms in psychometrics. Pag-aaralan naman natin next time yung mga next na mga techniques, no, on how to assign meaning to different raw scores. If you have any questions, don't hesitate, comment lang kayo sa baba, and I'm going to do my best to answer your questions. Okay, so thank you everyone for listening. Until next time, and God bless.